So we were discussing the subgroup analysis and the five basic analytical measures that we are to understand for the subgroup analysis. So let's go for the modularity. It's also known as Newman modularity, right? Because this modularity tells us uh, what is the strength of a division of a network into communities in terms of, are the people in the same group connected with each other more than people among the um, uh, across the groups, or people connected randomly. So as you can recall that, what type of subgroup is this which is actually measured by modularity? It is the Newman subgrouping, right? So modularity is to what extent the network links are actually forming the communities, right? So it is also known as Newman modularity. So if there is, say, there is a network in which there are three different components, the modularity of that network, it's a network level measure, right? So now modularity of that network will be very much close to 1. Why? Because there are three different set of nodes which are connected among themselves, components, but they are not connected across the network. They are not connected. One group, a node in one group is not connected with another group. If there are three clusters, then the modularity again will be a little bit higher, closer to 1, maybe more than 0.5. If there is a mixed sort of structure in which there are few nodes which are dense in connections, but there are out of the group connections as well, then the modularity will be somewhere less than 0.5 or around 0.5. And this, if the modularity is 0.2, say 0.2, it means the groups. So in order to calculate the modularity, first of all, we need to define the groups, right? What are my groups? So we can define the groups by attributes, we can define the groups by Newman, we can define the groups by Conquer, and then we calculate the modularity. So of course, when we calculate the modularity based on Newman grouping, the modularity will be higher, because the way the Newman algorithm makes groups is based on actually the connection among the nodes. This is what the modularity actually measures, right? So this way, the modularity is higher whenever we make Newman grouping. The modularity is very lower on somewhere between 0 and zero point 0.2 or zero point 0.3 when we actually making groups based on Conquer. Why? The Conquer grouping inherently is not based on connections of nodes among one another. So groups are not based on if two nodes are connected among one each other, we make a group. No, they are rather formed based on the connection patterns of nodes with other nodes. So that's why it's equally important. It's equally possible rather that a Conquer group in which there are three nodes, they are not connected with one another at all. So that group is still a group. There is another group of five nodes which are not connected with one another but have similar connection patterns with other nodes. So we can have three or four Conquer groups, but the modularity of this network, when we have made groups based on Conquer, will be very much close to 0. Why? Because the groups as we have made, they are not actually inherently connected among themselves and not less connected across the groups. So value ranges from -1 to +1, but practical values are usually between 0 and 0.7. Higher modularity, it clearer, denser communities. Communities means the links within the community are denser, and the links outside community are weaker. So if it is less than 0.3, weak or unclear community structure within the group, 0.3 and 0.5, moderate community structure. So keep in mind that modularity, whenever it is calculated, first of all, you need to define what are my groups. You cannot calculate modularity of a network without defining the group. If some software is giving you the value of modularity before defining the group, before asking you what sort of groups you are going to make, then that modularity is by inherently Newman modularity. It means the system is assuming that you are actually making the groups, subgroups based communities based on Newman algorithm, which is where the modularity is highest. So if it is more than 0.5, it is usually said in the social networks, it's a strong community structure. So we can think of what does a negative modularity represent. So, and I advise you to go to and explore this question, right? What does a negative modularity represent? So then the second important thing, how do we calculate the modularity? So there has to be some, again, I would ask you to go and just explore this. How do we calculate modularity? Its mathematical formulation is beyond the scope of our course, but it is something that calculates, okay, for each group, they calculate the number of links within the group and number of links outside the group. And then they do some calculations to come up with, okay, the modularity is either close to 1, more than 0.5, or less than 0.5, or sometimes negative as well. So negative would be, right, that if the links within the group are 5 and the links outside the group of these nodes are 7, it means this group is more connected outside the group than within the group. That will become the negative modularity. If the connection within the group are 5, connection outside the group are also 5, right? A very simple case scenario, although this may not be the very exact formulation of the modularity formula, then we say the modularity is 0, and this way it works. The second important measure is the group membership. What does it represent? Which node belongs to which group? So when we make groups and then we analyze, okay, if there are 70 different nodes, 70 different agents in my subgroup analysis, which node is belonging to which group? So algorithm specific inferences, if the groups are actually made based on Newman grouping, then the group membership will tell you, okay, this particular agent is more gel with this group A rather than group B. Either this can be a political grouping, this can be a social grouping. If it is an attribute based grouping, then of course this particular agent belongs to attribute, for example, accounting department or finance department, and etc. So some of the examples of using it: group members have more intense in-group connections and less out-group connections, right? This is when the Newman algorithm is in place. Concal algorithm, group members have similar networking rules. So if the two agents are in the same Concal group, it means they have a similar roles in terms of their interaction patterns with others. So which community detection algorithm will you use for following? Studying research collaboration in a university. Who collaborate with whom, right? In a university. Studying supply chain brokers, right? So just think about it and reflect it. The third important measure is the block model. What is a block model? It is a subset. A block is a subset of a network. The block model rearranges the adjacency matrix so nodes from the same subgroup appears together, right? So we make the we reshuffle the adjacency matrix rather than in the sequence of either their IDs or any other sequence. We make them in the sequence of their groupings. So for example, if node number 1, 2 and 3 are belong to the same group, node number 4, 5, 6 belong to the same group, node number 7, 8 belong to the same group. So we do the grouping a priori and then we make this block diagram. And the same matrix we do for the rows, and then we put the adjacency signs. Either, for example, it is unweighted network, so 1100. So for example, if this one you see, so the number of links of this particular group, right? Node A, B, and C, or node 1, 2, and 3, whatever you label it, right? The count of links within the group are 4, and the count of links outside the group, this group links outside the group are 3. If you come from here, this is also 3, right? So it is most likely it is a symmetric network, maybe, right? So this means this is most likely a Newman algorithm based clustering. But why? Because the number of links within the group are 4, the number of links outside the group are 3. Also, if you see the second one, the number of links within the group are 1, 2, 3, 4, 5, 6, and the number of links outside the group are 5. Whether you see 3 here and 2 here, or you see from this perspective, column perspective, 3 here and 2 here. And for example, GH, the last two, the number of links within the group are 2, and the number of links outside the group are also 2, right? So this group is relatively less intense a real group, but the rest of the groups are most likely based on Newman grouping. Why I'm saying this is based on Newman grouping? Because the pattern of the connection is actually showing this. Had it been a Concal grouping, or had it been attribute based grouping, uh, there may be that the number of links within the group are not actually the same as number of links outside the group. Anyway, moving forward, each block shows connections, diagonal blocks, links within the same subgroup, and off diagonal blocks, links between different subgroups. So subgroup analysis, understanding block models. So also we sometimes we put the densities, the values of the densities. Sometimes we put the adjacency matrices 1 and 0, and sometimes we put the densities. So for example, the density, 3 nodes connected with 2, so 3 twos are 6, so there can be a possibly 6 total connections, right? If self connection does not make sense, right? And if it is asymmetric, right? So there can be 6 different connections, but how many are there? There are 4. So 4 upon 6, the density is 0.67. Here then can be 6 different connections, right? 3 multiplied by 3, so 3 twos are 6, but how many connections are there? There are 3 connections. So 3 divided by, oh, sorry, we are working on the diagonal, right? So if the second diagonal, there are 6 connections and there are 6 connections, the density is 1. Over here, 2 upon 6, right? 2 upon 2, there are just 2 nodes. So 2 upon 2, so density is 1 within the group. Okay, so the cross diagonal densities, this group 4, 5, 6, 3 nodes can connect with these 3 nodes in how many different possible permutations? So 3 multiplied by 3, 9 different possible permutations, right? And how many links are there? There can be 9 different links, but how many links are there? 1, 2, 3. So 3 upon 9, the density is 0.33. Here the density is 0. Similarly, 3 upon 9, 0.33 density. If we work out the density over here, so these 2 nodes can connect with these 3 nodes in 3 multiplied by 2, 6 different ways, right? So 6 links can exist, but how many links are there? Just 2. So there can be 1, 2, 3, 4, 5, 6. So this is very easy. 2 by 4. This is 2 by 2 and this is 2 by 6. So this way all the densities have been worked out. So this is known as the block models or block diagram. So what this block diagram actually tells us, if we see this sort of a reduced block diagram, we will see in the next slide as well. This tells us to what extent group 1 is connected to group 2, to what extent group 1 is connected to group 3, and vice versa. So block densities can be determined by calculating the number of links in each block divided by the number of possible links. Example, intra and intergroup collaborations. So we see that intergroup collaboration is 67%, intragroup collaboration between 4, 5, 6 and 1, 2, 3 is 33%, for example. Reduced block diagrams. So what are these? When object of analysis is subgroup, not nodes. So within the same this block diagram, we now give away with the node IDs. We just say this is group 1, this is group 2, this is group 3. So now we do the subgroup level analysis, right? So we can have 2 different groups, for example, group A, group B, group A, group B. And what are the linkages of group A within group A? So this is the intergroup, something intragroup, and this is group A with group B, intergroup. So the object of analysis is now subgroup. It is not node anymore. And we no longer plot nodes, but we only plot subgroups and links between these subgroups. Different rules for what count as a link between groups. So what does this do actually measure? So there can be different modalities for this. Let's see what sort of modalities are available. So minimally connected criteria. So the one way of putting the numbers over here, whether it should be 1 or 2 or 0, is fully connected criteria. Different rules for what count as a link between groups, right? So for example, we say 2 links exist within group A and 2 links exist between group A and group B. So how does this 2 is arrived? Fully connected criterion, a link exists between 2 subgroups only if every node in one group is connected to every node in another group, right? So this is one way of saying, and if, of course, if this is the case, then most likely group A and group B, this will be 0, because it will be 1 if each of them is connected with each one of the other one. For initial cohesion, all nodes within this group must be connected for internal cohesion, right? So if we want a one to be here, so if we make this reduced block diagram based on fully connected criterion, right, then of course there will be either 0 or 1, right? There will be no weighted matrix. It will only be a binary matrix, right? So the diagonal internal cohesion will be 1 only if each node of group A is connected to each node of group the same group, then it will be 1. And this will be 1 only if each node of group A is connected to each node of group B, when we are saying it is the fully connected criteria. It is best used when you want to highlight very tight complete collaborations, right? So when we want to see complete collaboration in military or corporate teams, etc., we use this kind of configuration. Minimally connected criteria, which is the most lenient one. A link exists between two groups if at least one node from one group connects to at least one node in the other group, right? So this can be weighted as well. So 2 means there are two nodes connected within the group A, and there are two links between group A and group B. So this can be weighted as well. This can be binary as well. So binary means if any node in group A is connected to any other node in group B, it will become 1. Otherwise it will become 0. And if we are showing the count of links, as just be shown over there as well, right, then actually this is a sort of a weighted group. So minimally connected can be have weighted, but the maximally connected can have just the binary one. Density based comparison, most common analytical tools. So here what we do, compare the density of connections within the and between the blocks and overall density of the original network compared to. If a block's density intergroup or intergroup is greater than the network average, it is considered significantly connected. This offers a relatively normalized measure. So what does it mean? Again, it can be binary. So uh, just to make sense of it, if it is based on densities, so if the density of group A within the nodes themselves is more than the density of the overall group, there has to be a 1 over here. Otherwise, it is 0. If the density between group A and group B, as we just worked out over here, if you see over here, these are the densities, right? So for each of these densities, if these densities exceed the overall network density, there will be a 1 over here. If they are less than the overall network density, there will be a 0 over here. So this way of mapping the subgroup matrix is known as the density-based comparison. So this was the fourth measure, and the last measure is the internal external link comparison, which is also known as the Silo index. So let's see how it is going. So Silo index calculates how isolated a group is, and the formula to work out is internal links minus external links upon total links. So for example, if there are three groups, internal links within group 1 is 4, external links are 6, right? So internal links minus external links, 4 minus 6, which is minus 2, divide by total links, divide by 10. So the silo index is minus 0.2. It means if the silo index is 1, it means the group is absolutely disconnected with the rest of the world. If the silo index is 0, it means the group is neither disconnected with the rest of the world, nor it is more connected with internally within the group. And if it is negative, it means the group is more connected externally than internally. So if over here you see the group is more connected externally than internally, right? For group 2, 6 minus 10. So 6 minus 10 is 4. 4 upon total links is 16. So minus 0.25. Again, you see this particular group, group 2, has 10 links outside the group, 6 links within the group, 2 links within the group, 4 links outside the group. So if I ask you what kind of grouping, most likely what kind of grouping is this? This is the Conquer group grouping, because Conquer grouping has this kind of phenomena that the number of links, although it can be attribute based grouping as well, but attribute based grouping is somewhere in between. So the two extremes are the Newman and the Conquer based grouping. So plus 1 means what, minus 1 means what, and 0 means what. So this is something for you people to explore. So some vocabulary: communities, subgroups, clusters, a set of nodes with denser connections internally when than externally. So keep in mind, subgroup it should not be subgroup, right? Subgroup can be conquer based, and if it is a conquer based subgroup, then not necessarily the internal density is more than the external density, right? But if we use the term community or cluster, then generally means that the subgrouping analysis or the clustering or the community detection has been conducted on Newman algorithm. Clique we already know, component we already know, we have discussed it earlier. So global clustering coefficient and how it is calculated, modularity and how it is calculated. So global clustering coefficient, we have already gone through this concept. This is the uh, average of the local clustering coefficient. So clustering coefficient is to what extent each three nodes of the network are making a triangle, right? So this is a measure of local cohesiveness. So if and the average of all of them is actually the global clustering coefficient. So if the global clustering coefficient say is 0.7, it means that each three nodes have 70% of the chances that they are connected with each of them. It means the friend of my friend is also are also friending among themselves. So it is equally possible that there is a network in which there are three different modules, three different communities, clusters, Newman clusters, but the global clustering coefficient is very high because in each of them, the nodes are actually densely connected, right? So modularity is a measure of the community structure, the Newman community structure within the network, right? So it's a more global measure. This is the average of the local measure. Key clique, something to explore for you people. Structural equivalence and which community detection algorithm uses this as a basis of subgroup network. So this is another term which I want you to go through and then make sense of it. So that's it. In the next video, we shall see how we conduct this analysis in Oralite.